Hey guys, okay, so we're going to continue on our notes, but this is just kind of a unique question that I think you might enjoy, loosely put, might enjoy. So we're given this function, y equals x squared, let's do times 6 minus x, okay? And so here are the things they want us to do. So they want us to sketch this guy, okay, and we have no calculator, okay? And then verify that we've got the point -2, 32 is on the graph of y. I hate that they call it y. They should call it f of x, but whatever. Or, well, I guess I wrote it. I could change it. So verify that he's on the graph, okay? And then part B, which is of particular interest, for what values of k does x to the third minus 6x squared plus k equals 0 have 3 real roots. This is scary, right? No, we are not scared. All right, let's plow through this bad boy. All right, so I need to select a happy color before we attack him. I'm going to do this. Well, what colors haven't we used in a while? I guess what are some options here? Spend more. Ooh, look at this. Dark yellow. It's like gold. Let's do it. Let's see how it looks. All right. So, to sketch this guy, I didn't really go through this in the last video, so we're actually going to use calculus-based methods to sketch him. So for part A, I guess my first thing, just like the question we did earlier, is I'm going to distribute that x squared in. So I've got 6x squared minus x to the third. My goal is to try to find where I have maximums and minimums. So I'm going to take the derivative. So that is 12x minus 3x squared. Now, you can pause this and do this work on your own. You don't really need me to tell you all of these steps. And actually, that would be quite nice. So we're going to try to find the max and min. So I would suggest pausing it, doing it on your own, and then catching up with me later. But that's just me. All right, so after we take the derivative to get max and mins, I'm going to set it equal to 0. I'm going to factor out that 3x because it's a GCF, so I'm left with 4 minus x. And so my critical points are at, let's see, 0. That's where 3x equals 0, and 4. So what this means is if I make that little sign chart, I'm going to talk about f prime, I'm going to talk about f. 0 and 4 are on my number line, and this is where the derivative equals 0. I'm going to pick some test values. I'm going to pick to the left, I'm going to pick in the middle, I'm going to pick on the right of those values. And again, we sub into the factored form. Why do we sub into the factored version? Because it's just easier to look at the signs. So if I sub -1 into the first guy, 3 times -1 is a negative, 4 minus -1 is a positive. So that is a negative and it's decreasing. Okay. If I sub 1 into each, I'm going to get a positive times a positive. So it's positive and it's increasing. And last but not least, if I sub 5 in, it'll be a positive times a negative, which gives me, oopsies. I like this gold color. I can't believe I've never used this before. So if I wanted to write out the intervals of increasing and decreasing, I can, but if my end goal is to graph him, it's more important that I know where my relative minimums are and where my relative maximums are. And that's going to come from that number line. Because my original function is going decreasing to increasing to decreasing, I can see I have a relative min at 0 comma something, right? And I have a relative maximum at 4 comma something. I just need to get those y values. Because I'm trying to describe the original function, I'm going to sub those y values into my original guy. I actually think subbing it into the factored version is probably easier, right? X squared, 6 minus x. Subbing 0 in is easy enough because when you sub 0 in, you're just going to get 0, 0. So that was riveting. The next guy, when I sub in, what do I have to sub in? 4. So y equals 4 squared times 6 minus 4. 4 squared is 16. 6 minus 4 is 2. Oh, so that's not bad. 6 times 2 is 32. Yay! All right. So if my goal is to graph this guy, I'm going to go like this. And the reason I'm including these negatives here is because they want us to verify -2, 32 is on the graph, which I'll do in a second. But let me plot these points. I've got a relative min at 0, 0. Notice how I'm swooping it because I know it's a relative min. 2, 3, 4. It's good to use pencil. I'm going to put the 32 up here. I know it's a relative max, so I'm going to swoop it like that. What are some other things that would be useful if I'm trying to graph this function y equals x squared minus 6x? I don't know why I'm rewriting it. It's already there. X squared times 6 minus x. What are some other points? Well, I already have the y-intercept. I can get the x-intercepts by setting it equal to 0, right? So if I set this guy equal to 0, I can get my 2 x-intercepts, 6 minus x. So my x-intercepts are at 0 and 6. 1, 2, 3, 4, 5, 6. So when this guy drops down, he's got to pick up that little guy, right? So the other thing I know is that he's got to swoop like that, okay? And so the last thing that they wanted, and I got that from here, okay? It would be nice if I made this a little bit more like polynomial looking, but for the sake of time, I'm not going to erase it because you know how good I am at drawing. So the last thing we have to do, guys, is verify that the point -2, 32 is on the graph. Let's just say we believe it. Sub in -2, you should get 32 out. I'm going to plot it -2, 32, which is right here. All right. So here are all our points. This was 432. This was -2, 32, and now we're happy. So now when we look at that next part, it seems like they pulled this out of thin air, but they didn't, okay? So let's look at him. It says, for what values of k does x cubed minus 6x squared plus k equals 0 have 3 real roots? Notice how it's coming from this question. So it's got to have some form of a connection. And if you guys look at the difference or similarities between our original function and this guy, you'll notice, hey, look, the signs are just a little bit opposite, right? Because this is a -x cubed and he's a positive, and he's a negative 6x squared and he's a positive 6x squared. And then they just threw this random k in there. So if I'm looking at, so I'm just going to write part B down here. What they want us to do? X cubed minus 6x squared equals k. If I keep the k on one side and move the other guys to the other side, 6x squared minus x cubed, isn't that my original function? See? It's y. So they want to know if k is some number, and it's a sketchy way of asking it. K can be any number. Pick one. Oh, you picked 6? Cool. So if k is equal to 6, how many solutions are there to this equation? That's what it's asking, essentially, okay? So if I go to where k is 6, now be careful because we're looking at y values, right? So 1, 2, 3, 4, 5, 6, here it is. If I draw that across, how many answers do I have? Ooh, 1, 2, 3. So is that in my answer? For what values of k do I have 3 roots? Oh yeah, that's going to work. I've got 3 solutions there. I'll have 3 solutions as long as you're bigger than 0, right? Because that's where I have 2. Anything below here, I'm going to have 1. Right at y equals 0 or k equals 0, I'm going to have 2. So between, and I guess I can even use my highlighter. So starting here and ending up here, anywhere in between this span, I will have 3 solutions. Do you agree? So now what we have to do, guys, is we just have to explain how that works. So let's see. K needs to be between 0 and 32. Included, right? No, I can't include them because at 0 and 32, there are only 2 solutions. So, and it is enough work, guys, to just show the drawing on the graph. All right, so I thought that was kind of a fun example that we worked through together. Hopefully you had fun. I'm going to smiley heart star this one, and I'll see you later.